So the first thing that you'll see are your literal equations. Remember, literal equations are just equations that have pretty much all variables. And you are solving for a specific variable. In this case, if you'll look to the right, it'll tell you what variable you're solving for. We are looking to get a completely by itself. So you're going to look and see what's happening with the a. Right now, we just have something multiply. So if it's multiplying, you're going to divide everything by the m, which means you divide this whole thing by the m. On the left side, it cancels. So a is just going to equal the p minus n divided by the m, and you can leave it just like that for your answer. Remember, if you have multiple variables, then you have to group them, and you have to use distribution. Pull it out, and you'll have a group, all right? So you do have some where they're grouped as well. All right, so literal equation when you have two of them. When you have two of them, you want to get everything that has an a in it to one side. So like in this case, I want to move this MA over because I already have a BA on the other side. So I'm going to do that like I would anything else. I'm going to subtract it. All right, it will cancel. I have Z over here, and then just write it out. BA minus MA. All right, and you're going to use distribution here. Remember, if you have something multiplied by a number minus the same thing multiplied, you can write it like this, the A on the outside and the B minus M on the inside. That is just your rule for distribution, okay? And then right here between these is multiplication. So between the A and that group is just multiplication. And so if I am trying to get the A by itself and it is just multiplying by a group, I can actually just divide by that entire group. And on the right-hand side, that entire group will cancel. And now I have the A by itself, and that equals Z over B minus M. All right. The next section is proportions. And so you can have something like number 9, where you just have two fractions equal to each other. Or you can have something like 7, where you have a binomial in one of your positions, or more than one of your positions. Either way, you are going to use cross multiplication for these. So you're going to say 9 times V equals 2 times 7. And then you will just divide, and you can leave these as fractions. V equals 14 over 9. That's your answer. If it is something like number 7, you need to remember that this is grouped. So once again, you can say 7 times 6 equals 4 times that group. And so you do want to group it. And then you're just going to solve. 7 times 6 equals the distribution here. So we're going to say 4 times M minus 4 times 5. All right, to continue solving this, you are going to add that 20 to both sides. It will cancel on the right. You have 62 equals 4M. Your last step here is to divide by the 4. So M equals 62 over 4, and you do want to look and say, can I reduce? What goes into both 62 and into 4? 2. Yeah, so we can divide both top and bottom by 2. So my final answer here is 31 over 2. All right, when you have similar figures, you are once again just setting up ratios. You do want to make sure you're looking at it in the right order. So for this one, NM are my first two letters. So I highlight to this line right here, NM. And that corresponds to my first two letters of the other one, PQ. And so those two correspond to each other. You'll notice the orientation is different. You cannot just assume that what it looks like is what corresponds. You have to go by the letters that they give you. All right? And so that's why I use highlighters here. So then the next two letters are ML. So ML right here corresponds to QR. QR right here, which means the third lines correspond to each other. LN corresponds to RP. All right. And so I do that so that I'm making sure I set it up correctly. All right. And then I'm going to set up my equations. I want to first figure out what I'm looking for. I'm looking for this side right here. I typically use a variable there. All right, that's the missing side link, so that's going to be my variable. I put that on top. You don't have to, but I usually do. And then I find the one that it corresponds to. Well, I've already highlighted it at this point, so I can see that it corresponds to 14. And then I need to use one more set of sides, but I have to have both numbers. All right, so I have to have both numbers to do that. And so I am going to use the side RQ and ML, these two. All right. And so if I put the X on top, I need to make sure I put the 10 on top because it came from the same triangle. So that equals 10 on top here over the 20 on bottom. You can use cross multiplication. You can reduce first though. 10 over 20 reduces to 1/2. So 1/2 equals X over 14. Cross multiplication, or for something like this, you can say 2 times what equals 14? 7. So 1 times 7 is going to equal 7. Or you can always do your cross multiplication. 2 times X equals 1 times 14, and then divide by 2. So that missing side is going to be 7. All right, change the number given into the missing form. So fraction, decimal, percentage, whatever you are given, give me the other two, all right? So you were given a fraction. I need it in decimal and in percentage. For 3/8, you literally do 3 divided by 8. And as a decimal, that is 0.375. That is your decimal form. That's one of your answers. To get that in percentage, which is the only other thing you're missing, is multiply by 100. Or move your decimal place over 2 to the right. So if you multiply by 100, that's 37.5%. All right, so if you take your decimal and multiply it by 100, you get your percentage. Okay? For this next one, I gave you percentage, so I need fraction and I need decimal, right? Decimal's easy. Really just divide this number by 100 or move this 2 places to the left. So I had 72%, just move that 2 places to the left. As a decimal, that's 0.72. For fraction, you need to put whatever you're given in percentage over 100. For the fraction piece, you do want to reduce it. So you can start with something small. You know that 2 goes into both of those, right? If you see something larger, like a 4 goes into it, you can go ahead and do that. But you can do it by smaller ones. Just make sure you keep going, right? So if you do something like that, you don't know that 4 goes into it, you're going to get something like that. Keep going, right, until you can't reduce it anymore. Or if you can see a larger number, if you knew that 4 went into both of those, you could go ahead and divide both by 4. But either way, you want to keep reducing until you cannot reduce anymore, and then you've got your answer. Percent problems, there's 2 ways to look at this. The first way is that the percent times the whole equals the part. And so as long as you label those, you got it. Or you can do it as a ratio. The percent over 100 always equals the part over the whole. All right, so it's just figuring out which is which. The percent's easy. Obviously, the percent is here, or it will say what percent. All right, of what? Of always tells you where the whole is. All right, so this is the whole part, the whole, and this guy is the part. All right, so the other way to do it is just to interpret the sentence, okay? 86, well, I know what that means. That means 86. All right, is will always be your equal sign. Is will always be your equal sign. 240%, you always want to put your percentages as decimals. So divide by 100 or move it over 2 places. 2.4 will be my decimal. All right. Of is always multiplication. Multiplication, what is always my variable? Okay. And so you can do it multiple ways here. You can label your part, percentage, and whole. And you can say the percentage times the whole equals the part, or my ratios. Or you can just interpret that sentence into an algebra equation and solve, all right? And so once you have this, you're going to divide both sides by that 2.4, all right? And when you have 86 divided by 2.4, you should get 35.8. It says to the nearest tenth. So remember, to the nearest tenth means look one more decimal place. That's one decimal place. Look to two decimal places and decide if you round up or if you keep it the same. All right, and this would be your answer. For percent change and for the word problems are really just percent changes as well. So when I look at this, I just subtract those two. It does not matter what order you subtract them in, because you are going to tell me if it's an increase or a decrease. So you can just always subtract the smaller from the larger. So you can always subtract larger minus the smaller as your numerator, but your denominator must always be your starting amount, okay? This will always be your denominator. It doesn't matter if he's bigger or smaller. That will always be your denominator. And so you can divide that by 51. Remember, in your calculators, you want to group that. Do your 51 minus your 23 first, and then divide by your 51. And you're going to get a decimal here, right? This says round to the nearest tenth of a percent. So when I put this into my calculator, I get 0.549019. It just keeps going, right? You want to change it to a percentage first. So multiply by 100 or move that guy over. So I have 54.9019 and it keeps going. I want to round to the nearest tenth of a percent, which means I look at the second decimal. Below 5, I keep it. 5 or more, I round it up. So this guy is going to be 54.9%. And did I go up or down? Yeah, I went from 51 to 23, so I would write the word decrease here. That whole thing is my answer. Anna buys a sweater for $25.60 and it is on sale for 35% off. What is the amount of the discount? So these are really just percent problems, right? They're asking for the amount of the discount, right? Not the discounted sale price, but the amount of the discount. So I really need to know what I'm really solving for is the part that they're going to take off, right? So the whole times the percentage is going to equal the part that they're going to take off. These are identical to what we've been doing. And so for this one, I'm going to say, well, $25.60 is what it originally cost. It is on sale for 35% off. I'm going to write that as a decimal times 0.35. And so once you've done that, you have given me the discount amount. If it said what's the new price, then you would do your subtraction there. But this is really just asking for the discount amount, which is going to be $8.96, and you're done. If it said what's the sale price after the discount, you would take the original and subtract that. But it just wants the discount here. So make sure as you're reading through these that you answer the question. What is it asking for? So you're going to set up a chart. Your chart is always for these going to be rate, time, and distance. All right? You're either going to have two people or going there and coming back, right? In this case, I have two people. I have Shauna and I have Daniel. All right? Now, you're going to read through these and interpret, what do I have? What do I need? Shauna and Daniel left the hardware store at the same time. That's probably key. They drove in opposite directions. That's also important. Daniel drove 15 miles an hour faster than Shauna. After 3 hours, they were 435 miles apart. So the type of problem is opposite direction, which tells me that I am going to take the distance of Shauna and the distance of Daniel, and I am going to add them up, and they are going to be a certain amount apart, okay? So that's going to tell me what to do with my equation when I get it all set up. At the same time, do they tell me either time? Do they tell me anything about how long any of them drove? No, in fact, the question is find Shauna's speed. So the first two sentences don't tell me anything, do they? But keep reading. At the same time, I'm not done, am I? So part of the problem with the quizzes is y'all would read it and y'all would start setting up variables, right? And you're like, oh, time, then faster, and then you ended up with like 5 different variables, right? Keep reading. What does it tell you about the time?
Say 3 hours.
After 3 hours.
After 3 hours. Who? Why do I know that? At the same time. So just because you see something and you don't know what it is, don't start setting up variables yet, okay? Because you start reading it and you're going to think, okay, time, they both have a T. That's great. They actually both have a 3, right? Because after 3 hours, and they said at the same time. So after 3 hours tells me actually 2 things. It tells me both of their times, all right? My variable is actually in my question. What are they asking for? How, what? Fast. So they are asking for a rate. That is where my variable is going to be. It's going to be somewhere in my rate, okay? So all they tell me is that Daniel drove 15 miles an hour faster than Shauna. Do I know how fast she drove? No. I do not. So that's where I'm going to put my variable. 15 miles an hour faster. Does that mean I just say that he drove 15?
No, 15.
No, he did not. Yeah. He drove however fast she was going plus 15 miles an hour. All right.
Does that matter?
The other thing that I notice is you see a number and you just drop it into one of these boxes when it could be a number relating to something else, okay? Your distance is really easy. That column you multiply across. So 3 times x looks like this, just 3x. 3 times x plus 15. The other issue I sometimes see is that there's not parentheses there, and that will cause an issue, all right? Once you have this set up, you have your equation. You should have established at the very beginning what you're going to do with these. I'm going to add them up. 3x plus 3x plus 15. If you know you're adding them up, they have to be equal to something, which means somewhere in the equation they told you how far apart they were. If there was nowhere in the equation that told you how far apart they were, you probably are not going to add their distances. You're probably going to set them equal to each other. 435 is how far apart they are. And then I have a basic equation I can solve, all right? I'm going to distribute this guy right here. I'm going to combine my like terms. I'm going to solve for x. Subtract that 45. And then I am going to divide. So x equals 65. So now I need to make sure I solved for what they're asking for. They're asking for who? Find Shauna's speed. Where's my x? My x is for Shauna. If they had asked for both of their speeds, I would also need to put his. If they asked for just his, I would have added 15 to that, okay? But they asked for Shauna's, so I am done with Shauna's. All right, so there and back, they equal each other. If they are catching up, leaving at the same spot and getting somewhere, catching up with somebody, those are equal to each other. Distance apart, add them up, all right? But these are all the same. These should all look the same. You should have 2 of these, rate, time, and distance, set them up. You should have decided what you're doing with them once it's set up, and then just solve your equation. All right, so your chart looks a little bit different for mixtures. You should have a first, a second, and a final mixture, always. You need to determine what that is, all right? So if you read this one, it says vegetable oil, which costs $3 per kilogram, is made by combining soybean oil, which costs $1 per kilogram, with canola oil, which costs $4 per kilogram. Find the number of kilograms of soybean and canola oil required to make 18 kilograms of vegetable oil. So what I'm going to do is I'm going to go through and say, well, what are the 2 things that I am mixing? So in this case, I am combining. That's kind of an important word. I am combining soybean oil and canola oil. That tells me my first 2 rows here. I am combining soybean oil with canola oil. It tells me at the beginning vegetable oil. Don't immediately write that down as something you're mixing together. Read the whole problem. Vegetable oil is made by. That tells me that's my mixture, okay? So vegetable oil is my mixture. Now for these, you will have some units. In this case, kilograms. Kilograms of that particular substance. And then this one is going to be a cost. Sometimes it'll be percentage. So this is the cost per kilogram. And this is your total cost that you have, all right? Let's read for kilograms. Do they tell me anything about how many kilograms I have? Well, let's see. Vegetable oil, here's a cost. Soybean oil, here's a cost. Canola oil, here's a cost. So far, they haven't told me kilograms for any of it. Find the number of kilograms. Well, I'm going to be looking for kilograms of these two. Required to make 18 kilograms of vegetable oil. What did they just tell me? They told me the 18 kilograms of vegetable oil. Here's the thing. I'm trying to find both of the things above it. Well, I don't want two variables. So I'm going to I'm going to do X for one of them. They add up to 18. So if X is like 4, how would I solve for the other one? 18 minus 4. If it's 5, 18 minus 5. If it's X, 18 minus X. Okay? So anytime they give you the total mixture and they want you to find the other two, it's going to be a variable and the total minus the variable. Always. All right? Cost. Vegetable oil costs $3 per kilogram. Which row does that need to go in? Well, that needs to go in the vegetable row. $3. Soybean oil costs $1 per kilogram. That's going to go with my soybean. Canola costs $4. That's going to be with my canola. All right. To get the column over here, we just multiply across. 1 times X, 4 times 18 minus X, and 3 times 18. For this type, you don't have to decide. Do I set them equal to each other? Do I this? Do I that? No. The first one plus the second one always equals the third. Your last column is your equation. All right. So X plus 4, 18 minus X equals 3 times 18. And then you should all know how to solve that equation. Distribute, combine your like terms, subtract your numbers over, divide. Okay? It wants both. So once you solve for X, that will be your soybean. Subtract that from 18, and that will be your canola. And you will have answered both questions here. All right? I'm not going to take the time to solve it all the way out. But when you solve it out, you get X equals 6. That is how many kilograms of soybean? So 18 minus 6, that must be 12. 12 kilograms of this guy, because they must add up to 18. So these are my two answers here for those. To a decimal. Question.
Does it matter like what mix you put it in for 1 or 2?
No.
Okay.
As long as you keep it together. So for this next one, they have told me how many ounces of my second one. So I have decided I have ounces, percent peanuts, ounces of peanuts. They gave me one of them, 13 ounces at 70%. They mixed it with 7 ounces of 50%. That's my next mixture, 7 ounces, 50%, okay? If I have 15 ounces of one and 7 ounces of another, I should know how many ounces I have of my mixture.
20. No, 30.
So it should be 20.
Bro.
All right, 13 plus 7. This first column will always add down. All right? This last statement says, what percent of the new mixture?
X.
That's where my X is going to go. I don't know the percentage. You do not add the middle column down, ever. You don't add the middle column ever. But you always multiply across. So this is going to be 13 times, and we do change that to decimal. 7 times, and we do change that one to decimal. 20 times X. This last column is your equation. Add down. 13 times 0.7 plus 7 times 0.5 equals 20 times X. You're going to solve. It is talking about a percentage, so you will get a decimal here, all right? So you do need, so when you get this, you're going to get like something like 0.63. It might keep going, I don't know. So they do want what percent, which means that you need to multiply whatever you get by 100. It should have been 63% is what you're going to get for this one. So when you're doing these, real quick, kilograms. I'm going to look here and find my first column, kilograms. Percent iron. I'm going to look for that percent iron. That tells me my second column. My third column combines the units with the whatever it was looking for. And then you're just going to read through it. It needs to make. That is my final. Fill in what it needs to make. It gives me some other information. Pure is always 0 or 100%. Always 0 or 100%. Then you're just going to multiply across.